So, on to the example. So, here is our system that we're analyzing. All right, so you take a quick peek at what we're dealing with here. And I'm going to start right here. It is a single circle, so it's another way of indicating a pump. And the pump has a flow rate, all right, of 1.5 liters per second. So the pump is what dictates the flow rate in the system. So we do have our pump, and looking at my cheat sheet, we have our tank, pressurized air tank. We have our filter. So I'm just doing a quick run through of the components for myself. So when I start the question, I know where and what I'm doing. What do we have here? Okay, this might be something that's a little bit new, but this is a three-way or multi-way switch, or valve, I should say. So multi-valve. All right, and then here's our cylinder up here. Oops, not our clean cylinder. All right, so we have a bunch of information that allows us to move forward here. So the question says the cylinder press provided. So this is, say it's meant to bend metal for, say, horseshoes or whatever purpose we're bending the metal for. So that's what it does. It moves back and forth regularly. The rod extends from the piston to perform a repetitive task on the assembly line. The known quantities have been provided in the diagram, so we want to answer the following. So this will be a little tricky for me because I'm going to go back and forth or scroll up and down. So let's start with question A. Determine the volume of liquid moved in the cylinder during the power stroke. So the power stroke is the extension. Okay, so for A part, I'm going to mark it in green. We want to know what is the volume required to drive this cylinder outward. All right, so our flow rate, if you follow the triangles, I'm going to just show that the flow is going to come in here. So that's where our oil is going to come in. It's going to drive that cylinder out. So we are simply looking for the volume of the cylinder. So volume is equal to pi r squared h. So we'll use 3.14. What is the radius of that cylinder? It's 3.5 rod handle, and it's the head that we actually want. Okay, so the head is the information we want. The head is that measured distance there. Okay, so the height's going to be 35 centimeters, and we're going to convert this into meters. All right, so 10 centimeters, divide that by 100. So the radius is 0.1 squared, and the piston is going to drive a total of 35 centimeters, which is 0.35. So to fully extend the piston, we will need a total of 0.011 cubic meters of fluid or oil. All right, so that's how much we have to make sure is just needed just to drive that piston. So moving along now to B part then. B part wants to know the volume of liquid moved into the cylinder during the refill stroke. So just so you can have a visual on this, what's happening is that the cylinder is now going to retract. So now it's going to be way back here, but what's happening is this fluid has to go somewhere. All right, so what there is there's release valves in here, so the fluid will travel into this area here, and then will drain out back into the reservoir in this direction. Okay, so technically there is fluid inside your cylinder at all points in time, and that's why it's sealed. That's why you have a seal at the sort of the base of the or at the neck of the cylinder. It's to keep the oil inside. So what we're looking for is the oil that's going to occupy. Let's find a red pen here. This area here. So that technically goes all the way up the the cylinder part. So we're going to have oil in here, and you have oil all the time. So that means that you are going to have the volume of the cylinder, or I should say, all the oil that was used in the power stroke, because that piston is going to return right back to the bottom, all that oil is going to be shifted forward. So the volume in the refill stroke will be the volume from the power stroke minus the volume of the handle. Okay, the volume of the handle, because that handle is occupying space. The cylinder's not thin, right? That cylinder's in there occupying space. So we know the power stroke was 0.011 minus pi, and the radius of the handle is provided. It's 5 centimeters, so 0.05 squared times 0.35. And we do that calculation, and I get 0.011 minus 0.003. Let's say 3. So if we subtract that, so 0.011 minus the answer, I get 0.008 cubic meters. All right, so 0.008 cubic meters. So that's how much now is in that refill component of the cylinder. All right. The textbook, you can work in centimeters. I did convert to meters. It's not necessary. You can work in centimeters because that would convert to milliliters if you had cubic centimeters. So when you do the homework, if you leave it in centimeters, you're going to end up with milliliters, because cubic centimeters, 1 cubic centimeter is a milliliter. So it's fine to leave it in centimeters. You don't actually have to do the conversion. Okay, C part. Determine the total time of a complete cycle of the power and fill and refill strokes. So now we want to know what is the time for the cylinder to extend and then retract. So that comes from the following formula. So time is going to equal the volume of the power stroke divided by your volume flow. Okay, and the symbol for this is QV. And if we go back here, volume flow rate, the symbol's QV. All right, so plus the volume of refill divided by same amount, QV. All right, and we do that calculation there by entering in our values. So 0.011 divided by, and I've got liters per second, and this is where I run into a little bit of trouble. I shouldn't have maybe converted, because now I have to do a little bit of a conversion. It's liters, and I have to convert cubic meters to liters. So I'm going to do that factor for you. So I'm going to tell you that 1 cubic meter is equal to 1,000 liters. Okay, so I'm going to have to convert that. So what I'll do is, let's just erase that. So that means I've got to take my cubic meters and multiply by 1,000. So it's not a huge deal here. So the 0.011, we're just going to multiply by 1,000 to get it into liters. So that's 11 liters over 1.5, not 1.5. There's your flow rate from your pump. All right, plus the refill, again the 0.08, multiply that by 1,000 as well, and we get 8 liters divided by the 1.5. And when we do that addition, we get a total of 12.7 seconds. So therefore, a full cycle, it will take, let's say, 13 seconds for a full cycle. All right, so that means every 13 seconds, a piece of metal gets bent. All right, moving along. D, determine the magnitude of the force applied by the rod to the component in the power stroke. So remember from earlier in the unit, we know that pressure is force divided by area. So if I want force, rearranging the equation, it's pressure times area. Now, if we take a look in the question, it tells us in the valve what it's rated for. There's our pressure right there, 9 times 10 to the 6th pascals. So our pressure is 9 times 10 to the 6th pascals. And the area of the cylinder, so that area is the same as what we were using there. We're using that head calculation. So it is the pi. Radius of the head was, what was it, 10 centimeters? So 0.1 squared. Oops, and we're doing an area, so I don't have to do the height. So when we do that calculation, we get a total of 282,600 newtons, or 282.6 kilonewtons. So that's how much force is being applied in this system. So quite a significant amount of force. All right. And the last one, the E part, determine the work done by the liquid. So now we're doing our work calculation. And from the third unit, we know work is just force multiplied by your displacement or distance. So we have the 282,600 newtons multiplied by the stroke is 35 centimeters. So multiply that by 0.35. We get 98,910 joules. So that gives you all the different types of calculations you're going to have in the homework. If you have any questions, make sure you ask in class. Okay, and good luck.